We live on this planet Earth. We all know that we want to leave this planet for our children. We know the importance of sustainability, and I think that's what Landsat's all about. It's about helping us manage the planet that we live on for the long term. And that's why it's there, and that's why it continues to be here, and expect it to be there for the next generation as well.
Hello, everyone, and welcome to a really cool interview we're going to have with Dr. Bruce Cook, who is a NASA physical scientist. He is the project scientist for the Landsat Next mission, which you have heard of at several of our Trees Around the Globe student research campaign webinars over the last several years. And Bruce is based at the NASA Goddard Space Flight Center. So good morning, Bruce.
Morning, Brian.
All right, can you tell us just a little bit more than what I mentioned about you, and then what you do with NASA?
Yeah, I'm a research scientist here at NASA Goddard's Space Flight Center, and I'm also a project scientist, and I'm working on the 10th in a series of satellites that's been tracking the changes on the Earth's land surface since 1972. So that's more than 50 years now that NASA has been developing and launching satellites for the explicit purpose of improving resource management and for protecting Earth's inhabitants here on Earth. A lot of people aren't aware that that's one of NASA's job, is actually turning the telescopes around and actually focusing here on Earth's resources, and that's what one of my responsibilities is.
Excellent. Yeah, that's one thing that we run into a lot at NASA, don't we? Where, when we talk about NASA, we think of, looking at the planets. We think of looking deep into space. We also think about, astronauts and space shuttles. But, we do such amazing work in Earth sciences at NASA. We do everything. And so thank you for joining us today for this short interview. But yeah, that's great. We've been really talking about Landsat a lot in the campaign because one of the major observations that we focus on for the student research is looking at land cover and how that changes over time, whether it be 5 years, 10 years, 20 years, 100 years. We're really looking at that, and with that 50 plus years of data from the Landsat series of satellite, and with Landsat Next to come very soon in around 2030. We're going to have such an amazing database of Earth science data that's really going to see how things on our planet have changed over time, how we can use that data to protect our planet, as you mentioned, and then really see how our planet's responding to a changing climate, literally every day. So a couple questions for you, since this is a Trees Around the Globe student research campaign. Let's talk a little bit about research. And, when students, as part of the campaign, they often have some difficulty figuring out what they want to research and how they want to do it. And I know with scientists such as yourself, when you look at what you want to do, you come up with some science questions, you come up with visions initially that help guide you to what you want a satellite to do and how it can benefit everybody, using that science at some point. So when you started to plan, with your colleagues, Landsat Next, what were some of the initial things that you were thinking about, like visions that you were having of what you want the satellite to do, what you want it to tell us?
Well, when you inherit a 50-year-old program, the first thing you want to do is you make sure you don't break it, right? That's the first thing you do.
Right.
But with a 50-year-old program too, is you always want to inject new technology into something like that. It's the same thing. You go to the store and you want to buy a new iPhone or a new phone. You want to get the latest technology, but you also want to make sure that you have continuity with the past too. That you want to have backward continuity with the past, so that you have this continuation of your time series of the previous measurements. So you have this backward compatibility with your existing measurement record. That may be continuity with the bands, the spectral bands. It may be continuity with the measurements, that you're having the same coverage, the global coverage. You want to make sure that you're getting that same comparison so that you can have this, what we call the ability to compare measurements not only from place to place on the globe so that they're comparable, but also to be able to go back into time. We often compare Landsat as being able to step into a time machine, that you can go back into time and have those comparable measurements both in space and in time. I think all of us know if you're taking a picture of some place with your phone or with my phone, we'll have two different images and they're not necessarily comparable because they're from two different cameras. But Landsat's cameras, even though this, as I mentioned, this is the 10th satellite, they're very well calibrated to one another such that we have comparable images, comparable data sets to compare the data from one imager, one instrument to the next over the long time series. And that's a unique aspect of the Landsat series of measurements, is that they can be compared over the time, over the length of this 50-year history.
That's interesting because that falls along the lines of one of the things that we ask the students to do and the educators to do when they're out taking observations. We ask them to do repeat observations in the same location so we can compare those. Granted, it might not be on the same device each time, but so they can compare those from each time they take a picture, whether it's a week later or a year later or 2 years later, so they can compare those images. And I also like what you mentioned about continuity of the data, because we don't want those nasty data gaps that we hear about. We want to be able to continue the data throughout time. So that's great. So with your thank you for that. And with your vision, and what you wanted it to do, with the continuity and being able to compare this, this imagery in the same location over a long period of time, you had to come up with some research questions, specific ones over time, that you really wanted to tie this vision to what you wanted Landsat to do. So are there any, how did you come up with any research questions? Did you do it as a team, or did the individuals came together at some point?
Yeah, this is where we really poked on the users themselves. It wasn't me making the decisions, and saying, hey, this is what we should do. This is where we went out to the community and we said, and the community is quite large. You can imagine over a 50-year period, there's a lot of people that use Landsat data. It's averaged at 40,000 people are using per week, are downloading data and using Landsat data. There's some 1 million articles. If you do a Google, Scholar search, you can find 1 million articles will pop up on your search. It's amazing the amount of people that have been using Landsat data and that comprise the community. So we had several surveys that were conducted of that community. We had a lot of user forums that were conducted. There were a number of white papers that were drafted. We had a lot of informational meetings with subject matter experts and such. And we polled the community to see what their needs were. And these needs evolve over time. They are not stagnant. And so there were three needs that popped up. One was the increased need for higher revisit frequency. Right now, a single mission was only revisiting the same spot on the globe every 16 days. And so we're going to be improving that by we're going to increase that to every 6 days.
Wow.
And then also the spatial resolution was at 30 meters, and that's going to be improved to 10 to 20 meters. So that's going to be improved. And then spectral information, we had 11 bands before, and now that's going to increase to 26 bands. So just about everything is going to be improved by about two to three times improvement. Wow. And that was based on the user community, not based on my decisions or anything like that, but based on the science needs of the community. And again, that changes all the time.
Sure.
You can imagine the needs back in the 1970s when fossil fuels were all the rage. People were lining up at the pumps and fossil fuels were what we needed. Now that's not necessarily the case. Fossil fuels are kind of on the outs, and maybe we're looking at more renewable fuels. And maybe sustainable fuels are more of our our need. So things change over time, and needs change. Water supplies are more important for a population that has doubled since 1970. When the first Landsat was launched, we only had a population of about 4 billion people on Earth, and now we have 8 billion people. So demands on our resources have increased quite a bit too. So needs change over time, and we'd be able to respond to that.
Yes, definitely change with the times, and I love that your team, took it to the users to figure out what they want, because that really brings out that this is a science we need for the real world. These are the real questions that the folks using the data, this is what they need the data for. This is what they need it, whether they're focusing on something locally, regionally, nationally, globally, but taking it and asking them, what they need. And we do that with the Trees Around the Globe Student Research Campaign. When we come in each year, saying, hey, this is what's happening this year. These are a lot of the missions that are going to be launched, or ones that'll be hitting, 5 years in space. This is what, these satellites are doing. What do you want to know about these satellites, and how can the data from these satellites help you as student researchers to, develop research projects that will answer questions in your local area, but will have a global impact.
Right.
So I think that your last answer to the question actually, tied together what was going to be my next question. So we don't actually have to go into that directly, but I'd like to finish up this discussion with you with do you have any words of encouragement or suggestions for students doing their own research? Like, what have you seen that may have worked that has worked for scientists, in the past and present, that students can really adopt, when they're deciding on or actually doing research projects?
Don't get caught up too much in the technology is the question. And I think you hit on that too. It's really identifying the needs, identifying the problem is really the key part of it. The technology, the R&D and things like that. It's really not about putting the parts together. It's coming up with the good ideas. I've seen a lot of people get enamored by their technology, but it's really being able to answer the question about so what and why should anybody care. It's really being able to identify that, and we come up with. Landsat is one of those things that it does address so many people's needs. We often call it the Swiss Army knife, because it does address so many people's needs. We don't talk so much about the technology, but we talk about how it meets people's needs and the benefits to society. We don't talk so much about the technology. We do develop the technology, but it's really the needs that puts us on the map. And or I guess you could say it puts science on the map, if you want to put another buzzword in there.
Yeah.
And I think also it also helps us prepare us for the future. That is the other thing too, is that is being able to really to really think about how remote sensing can answer questions or answer problems. Not identify problems, but actually answer problems. I think too many times we think about it as remote sensing as identifying problems, and really actually should be there to solve problems. It's seen as a positive insight, and prepare us for changes. There are a lot of things that remote sensing can do to help us better identify change. Whether it's in the case of tree growth and things like that, we can use trees to help us better develop windrows that can better produce crops, that can better protect areas, that we can use tree growth to help us determine what forest management practices work better and to make us better productive in terms of growing crops. And I'm talking about tree production here. So, you know, there are things that we can do with remote sensing that can actually be a very, very positive thing, even though you see in the news sometimes forest fires, earthquakes, and things like that that we see from remote sensing. I think there are a lot of positive things we can do with remote sensing too. So I'll leave it with that, I guess.
That's great. Thank you. Yeah, I love that, where, you know, one of the ultimate goals is to, you know, that the data, you want it to provide answers. You don't necessarily want it to come up with problems. You want it to provide answers. And, you know, with Landsat Next, you know, we're super excited about this. You know, we are, what, about, you know, 6 years away from it, but we just can't wait for this, you know, not to get caught up in the technology, as you said, but we're super excited about the amazing technology that Landsat Next is bringing forth. So, and, you know, we're going to be able to, you know, we're going to get a lot of data, you know, from this mission, that, and we'll be able to use the existing, you know, the 52+ years of data with Landsat, you know, tie that up in with Landsat Next, and we just can't wait to see, you know, what type of data set, you know, that we're going to be able to use, and that students can use as well in their data when they're comparing their ground-based data to the space-based data. So with that said, I want to say thank you so much, Dr. Cook, for coming on here and talking to me today, and looking forward to Landsat Next, and thank you so much.
Okay, take care. Thank you very much for having me.